It's your friendly math tutor, Miss C here, and today we are talking about trig identities. Not all the identities, one identity in particular, and that today is the Pythagorean identity. Okay, there are three different Pythagorean identities, and we are looking at one in this video, and that particular identity looks like this. Sine squared of theta plus cosine squared of theta equals 1. So keep in mind that theta is just our variable, and theta could be replaced by any other Greek letter, any variable. So you're going to notice in the identity we're proving our variable is x. So this could read sine squared of x plus cosine squared of x equals 1. All right, here's what's important about this identity. This is the way that we normally see it, but this identity can also look like this. We can manipulate it so that it looks like this, or we can manipulate it so it looks like this. So how I know to use this identity is when I see something that I'm trying to prove, right? An identity I'm trying to prove, or I am trying to solve an equation and I see that there's sine and cosine and one of them is squared. I'm going to try to use this identity because it gets me down to a single trig function. So let's look at our example that we are trying to prove, and I'll show you what I mean. So in this example, I have 1 minus sine of x divided by cosine squared of x equals 1 divided by 1 plus sine of x. So here's what we're not doing. We are not trying to solve for x here. When it says prove the identity, it's basically saying make one of the sides of the equation look like the other, show that they are equal. So we do this by working one side of the equation. The reason I know I'm going to use the Pythagorean identity that we just talked about is because I've got a cosine squared of x in the denominator here. And when I look at my final goal, I only have sine. So what that tells me is I have to figure out a way to get rid of cosine. So let's go ahead and have a look at this. So I'm going to go straight away and think about how do I get rid of that cosine squared of x? So that triggers in my mind the Pythagorean identity right here. So everywhere I see cosine squared of theta, or in this case cosine squared of x, I'm going to replace it with 1 minus sine squared of x. So that will be our first step. So sometimes we can look at these like a puzzle that we're trying to solve. Okay, so that's step one of our puzzle. So what I notice is I'm pretty close, but I'm not quite there yet because I still have a sign in the numerator and my sign in the denominator, not the sign, but the sign of my operation, which is negative, needs to become positive. So I'm noticing something else that is important in the denominator that is going to help us. So I'm noticing that I have 1 minus sine squared of x. So some people might be tempted to just cross things out. You cannot do that right now because there's no multiplication happening here and you've got subtraction signs. So we can't simplify the numerator and denominator at this point. But what we can do is deal with this 1 minus sine squared of x. So this is called a difference of squares. Okay, and what that basically means is that because there's no middle term to this trinomial, right? It would be the 0x term. What I know is it follows a rule. So I'm going to rewrite the numerator as is, and here's how I do my difference of squares. I end up with 1 minus sine of x and 1 plus sine of x. If you're not familiar with how to do that, check out some YouTube videos on those, because anytime you have a function that follows this rule, it behaves the same way. Just like I showed you, one binomial becomes positive, one binomial becomes negative, and that cancels out the middle term. All right, what this means for us, right, is that we now have a product of two binomials in the denominator, which means we can simplify our fraction, right? So I have 1 minus sine of x in the numerator, and I have 1 minus sine of x in the denominator. And the denominator is being multiplied, which means we can now reduce these. 1 minus sine of x divided by 1 minus sine of x is 1. Okay, so that leaves me with 1 in the numerator and 1 plus sine of x in the denominator. And guess what? That is exactly what we were trying to show. So we just proved our identity using the Pythagorean identity. If you found this video helpful, please like it so it shows up for other people. And don't forget to subscribe for more math content. Till next time, remember, you've got it.